Good morning, everybody. How are you today? I hope that you're doing really, really, really awesome. So, this introduction to statistics material that we've been covering, it's very vocabulary intensive, and there are some things about it that when I took it, I found I wasn't always confident in my responses. Sometimes I would overthink things. So today's going to be one of those days where I really, really, really try to show you the differences between things and to show you definitions from a couple of different perspectives, hoping that in so doing, there won't be this gray area with your choices, with your understanding of this vocabulary, that you'll understand more clearly. But it's going to take a little bit of a while. And I suspect today might be one of the longest days in terms of the videos that we will have all year long. After this, we get a lot more math oriented or numbers oriented, I should say. So I want to begin, because of all of this vocabulary, with where we left off at the end of the last lesson. So if you would do this particular slide, it's the same exact one from the last lesson, but let's see how much of this material you have retained. You know the deal. We're going to do stop and start, where you stop the video, start it up when you're done, and I'll go over the answers that you may have found. Okay. So we've got in identifying the population, it's all of the adolescent boys taking the meds. Remember, the population is everybody. And the sample is always a small group of the population. You'll remember the slide we gave with the great big box with all the little markings or dots in it. And then out of that, there was a smaller box with less markings. That less marking box is the sample box. The big box is the population box. Okay. To define the terms parameter and statistic. All right, parameters are derived from the entire population. Statistics are derived from the sample. That's the big thing, is that parameters come from the entire population. Statistics come from the sample, and that's that mnemonic PPSS. Statistical methods are classified into two major categories: descriptive and inferential. Describe the general purpose. 4 statistical methods in each category. Descriptive stats summarize data, and inferential stats derive from a small group and apply it to a bigger group. So in other words, if you saw a pie graph based on how a family, or how a particular workforce is paid, and everybody in the workforce's salary is included in the pie graph, then or even if it wasn't everybody, that data would be a descriptive data, because it's describing, key root word there, everything about the data in the company, and it's not taking conclusions from a few and bringing it to the many. So descriptive stats, you're dealing with the entire company, you're dealing with all of the salaries written out there, and it summarizes that data in the terms of like a pie chart. With an inferential stat, we derive from a small group. Let's say we took a few people from that workforce, and then we drew a conclusion about those 2 people, and then we said, oh, well, if it works for those fewer people, not 2, but fewer, then it also has to apply to the big group. All right, so that's where we left off last time. Now, another little practice question to go over some of this recent vocabulary. You can read the question yourself, and it gives you what the key terms are that we want you to define. If necessary, when you pause the video, write those words down so you know what you're looking for. Okay, the population is all medical doctors listed in the professional directory. The parameter is going to be the proportion of medical doctors who have been involved in one or more malpractice suits, and that's because the parameter is based on the entire population. The sample is the 500 doctors that they took out of all of the doctors. See, if you're looking at a directory, it lists all the doctors, so that's why it's a population. And the statistic is the proportion of doctors who were involved in a medical malpractice suit in the sample. So the statistic comes from the sample, the parameter comes from the population. The variable X is whether or not a doctor's been involved in a malpractice suit. That's what can change from doctor to doctor. Were you involved, yes or no? And the data are either, data being the outcomes, either yes, you're involved, or no, you are not. Okay. Now we move forward into the last section in chapter 1 that we're going to cover, 1.4, variables and measurement. I just wanted to do a little bit of housekeeping before we proceed further. Okay, the housekeeping that I want to do involves there'll be a quiz after Wednesday's lesson. It'll open up online. You'll have 2 days to do it and get it back in again. You want to make sure the homework from lesson 2 is complete before Wednesday, as it will help you a bunch with the quiz. All right, so make sure you get that done. It's kind of, my quizzes are based on the work that you've been doing in class. I'm not trying to blindside anybody with anything. And last, I did send you the calendar or schedule of the lessons, but it is very fluid, being that this is the first time that I've taught this course, and I want to make sure that I can maintain and keep a good pace. There are several review days written in at the end, just in case we need to take a little more time with a particular topic because you don't understand it. I don't expect that, but it could be. All right, so we're going to talk about variables and data today. So the variable is like in the last one, yes, you did, or no, you didn't get a malpractice suit. In this case, there are, of course, 2 types of data. There are qualitative and quantitative. And within quantitative, there can be discrete data and there can be continuous data. And this terminology will relate to terminology that we have already learned. Okay. Now, qualitative data, a qualitative variable is sometimes referred to as categorical because it's like a category, or it's a quality, and that's for the type of data. Now, these variables are variables that take on names or labels that can fit into categories. Okay, they don't have numerical values. And quantitative variables are sometimes referred to as numeric variables. They are variables that represent something measurable. So, for example, height, weight, time, something to that effect. All right. And here's a little video that we have. You know what? I'm going to save this video because we'll never be able to fit it all in. So I'm going to pause this slideshow at this point in time, put up the first video, and then this video on categorical versus quantitative variables, I'm going to play this for you as part of the next video in the series.